Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. In the last video, we graphed sine x, cosine x, and tangent x. But those three functions have reciprocals. These are new trig functions built by flipping the fraction. Today, we'll introduce them, see how they behave, and learn their key properties. We're going to do one of them carefully together, and then we'll use technology to generate the others. First, let's introduce the notation. The three reciprocal trig functions are secant theta, cosecant theta, and cotangent theta. And intuitively, you can think of it as secant theta is 1 over cosine theta, cosecant theta is 1 over sine theta, and cotangent theta is 1 over tangent theta. So now the definition of secant and cosecant are exactly as they appear here. However, for cotangent, intuitively, you can think of it as 1 over tangent theta, but the actual definition is cosine theta over sine theta. And it's important that we make this distinction because it's going to show up later in an example. Now, let's take a look at what the graph of cosecant theta looks like. So on the page here, we can see that we already have the graph of sine theta. And since cosecant theta is 1 over sine theta, we can think of it as taking each of those values on this graph and doing 1 divided by that value. So for example, if we're talking about this value here, the y value here is 1. And if we do 1 divided by 1, that's also going to be 1. And then as the y value decreases, if we take 1 divided by a number that's getting smaller and smaller, then our number is going to get bigger. So therefore, we're going to start slowly increasing from that point. And then we can see that here, the y value is 0. And 1 divided by 0 is going to be undefined. So therefore, our cosecant function is going to have a vertical asymptote at x is equal to pi. And similarly, we can see when x is equal to 0, we have a y value of 0, which means we also have a vertical asymptote here. And then in fact, we have a vertical asymptote at every multiple of pi. So we're going to go ahead and draw these vertical dotted lines. So then continuing with the original graph that we were drawing, it's going to get steeper and steeper, and then it's going towards infinity. And then same thing on the other side, because we can see that the value is getting smaller and smaller and going down towards 0. So therefore, our cosecant is going to get bigger and bigger and then go up towards infinity. Now for the next part of our curve, we have the y value here is -1. And 1 divided by -1 is just -1 as well. So we're going to start from there. And here we can see that the value is getting closer and closer towards 0. But it's a negative number. So 1 divided by a negative small number is going to go towards negative infinity. So which means our cosecant graph is going to look like this. And then it's going to look the same on the other side of that dot. So this one is going to be identical. So let's go ahead and draw that. So it'll go down. And then finally, let's finish up and draw the last one. So it'll look like a bowl. And then, oh, we forgot our vertical asymptote. So let's add that over there. So now that we've drawn the graph for our cosecant theta, let's go ahead and use Desmos to show what secant and cotangent functions look like. So let's start with our function cos of x. So if we use a similar method, we would expect to see a vertical asymptote wherever cosine is equal to 0. So which means it's going to be at -pi/2, +pi/2, 3pi/2, and so on. So let's go ahead and show what the secant function looks like. And that's exactly what we expected. So it's going up towards infinity when cosine function is positive and going towards 0. And it's going towards negative infinity when the cosine function is negative and going towards 0. And then lastly, let's take a look at our tangent graph. So this is our tangent curve. Using the same method, we should expect a vertical asymptote at 0, at pi, at -pi, and so on. And then we can see where tangent is going towards positive infinity, our cotangent should go towards 0 because we're taking 1 and dividing it by a really large number. So let's take a look at our cotangent curve. So here we can see that this purple curve is our cotangent x, and when tangent is going towards 0, our cotangent is going towards infinity or negative infinity. And when tangent is going towards infinity or negative infinity, our cotangent curve is going towards 0. So now, armed with this knowledge, let's take a look at how we can evaluate some of those reciprocal trig ratios. We want to evaluate secant of 60 degrees, cosecant of pi over 4, and cotangent of pi over 2. So secant of 60 degrees, that can be written as 1 over cosine of 60 degrees. And from our special triangles, we know that cosine of 60 degrees is 1 over 2. So this is 1 over 1/2. And that is going to give us 2. Now cosecant of pi over 4 is 1 over sine of pi over 4. And sine of pi over 4 is one of those special angles. So we know that is 1 over root 2. So then we just flip our bottom fraction, and this is equal to root 2. And finally, cotangent of pi over 2 is equal to cosine of pi over 2 divided by sine of pi over 2. So we know cosine of pi over 2 is equal to 0. And sine of pi over 2 is equal to 1. So we have 0 divided by 1, which is equal to 0. So notice how I use the definition of cotangent instead of using 1 over tangent. So let's take a look at what would happen if we used 1 over tangent of pi over 2. So if we said that this is equal to 1 over tangent of pi over 2, we're going to get this is 1 over undefined. And that's because tangent of pi over 2 is undefined. And from our composite function unit, we know that if we can't put pi over 2 in our tangent function, then pi over 2 is not in the domain, which is why we can't use 1 over tangent x as the definition of cotangent. It's just for you to kind of visualize what the graph looks like. But the actual definition of cotangent is cosine over sine. Now let's take a look at another example. So if we have sine theta is equal to 3 over 5, where theta is in quadrant 2, we want to find cosecant of theta and cotangent of theta. So to do this, we're going to draw a diagram. We start with our x and y axes, and then we're going to draw our theta. So our theta is in quadrant 2, which means it's going to be somewhere over here. So our reference angle is going to be this angle right here. So if sine of theta is 3 over 5, that tells us the opposite side is going to be 3, and then the hypotenuse is going to be 5. So here we can use our Pythagorean theorem to find the missing third side. So we know 3 squared plus x squared, because that side is our x, is equal to 5 squared. So then we get x squared is equal to 25 minus 9, which means x is equal to negative 4. And we know that's negative because we're in quadrant 2. And now we're ready to find these reciprocal trig ratios. So the first one is cosecant of theta. So cosecant of theta is equal to 1 over sine theta. And that is going to be equal to 1 over 3 over 5. So therefore, this one is equal to 5 over 3. Now cotangent theta, again, is equal to cosine of theta over sine theta. So cosine theta is adjacent over hypotenuse, And since our adjacent is x, which is -4, this is -4/5. And then our sine theta is 3/5. So we have -4/5 over 3/5. And this is equal to -4/3. So now let's do a recap of everything that we covered in this video. We learned how to create the graphs of reciprocal functions from the basic trig functions by thinking about 1 divided by the y value of the basic trig function. We learned how to evaluate exact values using these trig functions. And finally, we started to look at how to solve trig equations with these trig functions. And now it is your turn to give this a try. Can you solve this trig equation on the screen here? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on reciprocal trig functions in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.